Welcome to Saxon Math Course 3, Lesson 102, which is about growth and decay. Growth and decay are real-life concepts that can be shown with geometric sequences. Growth would be a sequence that shows an increase. The numbers will be getting bigger and have a constant ratio which is larger than 1. That means that if we divide any term in the sequence by the term directly before it, you'll get a number bigger than 1, and no matter which term you pick, you will always get the same answer for your division. In a decay, there will be a sequence that shows a decrease. The number will get smaller, and the constant ratio will be between 0 and 1. That means that when we divide each term by the term before it, we're going to get some decimal or fraction. Example 1 says, the population of a country has grown 2% per year for the last 5 years. If the country's population is 1,200,000 now, what will the population be 3 years at the current growth rate? So to do that, all we're going to do is we're going to multiply the current population by the growth rate, plus 1. The growth rate is how much it grows by, and 1 is how much they already have. If you put 1 with the growth rate, then you'll have the new total. So 1.02 is 1 plus the decimal of 2%. 2% is 0.02. Now, 2 times 0 is 0, 2 times 0 is 0. 2 times 2 is 4. 2 times 1 is 2. Then I need to drop 2 zeros before I go to the 1 because it's in the third position. And then we have 1, 2, 3, 4, 5 more zeros. And then a 2 and a 1, which will give us 1, 2, 2, 4, 0, 0, 0, 0, 0. But remember, we have 2 decimal places in 1.02, so we have a decimal place here, giving us 1,224,000. That number then goes up here. We're going to have a similar pattern of 0, 0, 0. 2 times 4 is 8. 2 times 2 is 4. 2 times 2 is 4. 2 times 1 is 2. Then we're going to have 1, 2. 1, 2, 3. And then 1 times 4 is 4. 1 times 2 is 2. 2, 1. So then we'll have 0, 0, 0, 8. 4, 8, 4, 2, 1. We'll have 2 decimal places, meaning that our new number is 1,248,480. Which when we multiply, 2 times 0 is 0, 2 times 8 is 16, 2 times 4 plus 1 is 9, 2 times 8 is 16, 2 times 4 plus 1 is 9, 2 times 2 is 4, 2 times 1 is 2. And then I'm going to put 2 zeros as I'm going to the 1. 1 times 0 is 0. 1 times 8 is 8. 1 times 4 is 4. 1 times 8 is 8. 1 times 4 is 4. 1 times 2 is 2. And 1. So we're going to have 0 plus 0 is 0. 0 plus 6 is 6. 4 plus 0 is 4. Or sorry, that's a 9. 9 plus 0 is 9. 6 plus 8 is 14. We'll get 14 again. We'll get 13. 1 and 2 and 4 make 7. we'll have 2 decimal places. So our final answer will be 1,273,449.6. All right. Now, it also asks, how long will it take for the population to double? Well, to do that, we're going to use our rule of 72. Our growth rate was 2, so 72 divided by 2 is 36, meaning that in 36 years, the population will be doubled. Example 2 says carbon-14 is a radioactive isotope occurring in nature. It is used to date materials containing carbon. Carbon-14 has a half-life of 5,730 years. If a bone is found that has 1/4 the amount of carbon-14 as a modern bone, how old is it? Well, to understand this question, we have to understand what a half-life is. A half-life is the amount of time it takes for a half of a radioactive substance to decay. So, if we have one whole substance and we take one half-life, which for carbon-14 would be 5,730 years, half of it would be left. In another 5,730 years, half of the half would be gone, and half of a half is 1/4. In 5,730 years, only half of the fourth would be left, which would be in 1/8, and then 1/16, and it would continue on in that pattern, 1/32, and so on. So if we look here, 1/4 of the substance being left is 2 half-lives, meaning we have to take 5,730, and we're going to multiply it by 2. Now 2 times 0 is 0, 2 times 3 is 6, 2 times 7 is 14, 2 times 5 is 10. Now, this is a multiple choice question. So we have to ask ourselves, 11,000 years, 5,500 years, or 2,700 years? Which one is 11,460 closest to? Well, it's closest to 11,000. So our answer would be A. This has been lesson 102, Growth and Decay. Make sure you stay inside, stay safe, and wash your hands. Make sure you also do all your homework.